Hey yo, it's Paper Cam, Wave of the Future. Today we're going to talk about this thing. I don't know what this should be called, but it's a trig function with a bunch of stuff attached to it, and when there's numbers here, it can look kind of scary, and you can feel like I don't know what that is. And I haven't thought through this since I was teaching it a few years ago, and so my thoughts might not be in perfect order, but part of the point of this channel is to show you that when you think about math, if your thoughts are not as organized as a math textbook, that's not a problem. That just means you have a human brain, and human brains don't always function in strict, perfect, outline based order. So we have this thing, and these little pieces have names, and I don't really know if the names help that much, like amplitude, phase shift, vertical shift. The period is hiding in there somewhere, so I'm just going to try to shed some insight on this, and we will take it from there. Now, in order to kind of get through this, you are going to want to know that the sine function repeats at 2 pi, right? Radians we're talking. So pi is 180 degrees. Pi over 2, 3 pi over 2, and then 2 pi. So let's take a look at this. And another thing, the sine function looks like this. You should know that in order to understand what we're going to talk about right now. And it goes this way too. And it just keeps going in this. It just repeats this undulation up and down, right? So that's the first thing you should notice. The sine function, the lowest it ever is -1, and the highest it ever is 1. No matter what value I ever, because this goes on forever this way and forever this way, and that's all the sine function ever does. It goes up and down between -1 and 1. So if you have something sine y equals sine, and there's a bunch of stuff in here, it doesn't matter what it is, x squared minus square root, blitty blitty blitty, this is only going to go up and down between -1 and 1. Maybe it'll go fast, maybe it won't start here, but it will only ever go up and down between -1 and 1. And I've said that about 3 times now because I want you to think of sine something. I want you to think of this as a little machine that just goes up and down between -1 and 1. And just stare at this until it feels like that's what it is. Alright? So now, let's look at this number out front. A. What if A is 2? What's 2 times 0? Well, that'll still be 0. And 2 times these numbers in here, well, they'll just be double them. What's 2 times 1? Let's actually write 2 sine here so we remember what we're talking about. Right? 2 times the maximum of sine will be 2. And then 2 times -1 will be -2. So can you see what this number is doing? It's changing the max and the min because this number, remember this is just a machine that goes between -1 and 1. And so this thing that we're tagging on the front, what it does is it makes the 1 into this, and it makes the -1 into this. So this is the new max and min, whatever you put here. Let's put a half there, right? A half times sine of x. So now, remember, this is a little machine that goes from -1 to 1. So when this is at its max, it's going to be 1 times this. When this is at its min, it's going to be -1 times this. And that's the highest and lowest it can go. So whatever is out here is the highest and lowest that this can go. Because what is this? It's a machine that goes between -1 and 1. Alright, so let's look at the other pieces. I think we'll treat one at a time and then we'll let you synthesize them in your mind. So let's say we have this. Y equals sine, and then I add something inside there. X plus, let's say pi, right? So we're going back to here and we're saying sine is this thing that goes up, down, up. And here's the point at which it repeats. Okay. And so this is 2 pi, and this is pi. Hopefully that's big enough that you can see it. Let's draw it again. I don't want to just hope. I want it to be true. Alright, so this is pi, and this is 2 pi. And this is 0. So, we know that on the regular one, right here, if I put sine of 0, I'll be here. But let's say I put 0 into this one. If I put 0 into this one, then it's taking the sine of pi, which is here. Okay? What if I have this? Y equals sine x plus pi over 2. If I put 0 in here, what am I doing? I'm taking the sine of pi over 2, which is here, right? So instead of being here, I'm here. So I think of this as sort of like a fast forward. Because it's sort of like, well, if I put in 0 in here, it already gave me pi over 2, right? So I'm going to be further along on my curve than I would have been just with regular old sine of x, you know. Sine of x is this. This one here, we label it sine of x. But if I do sine of x plus pi over 2, then I start here. So if I put in 0, I get this, and then whatever value I put, like if I put in a certain amount, I'm going to be starting further out by this much. So this is like another way you could think of this. This is a head start. Alright? Head start. Maybe I'll label these as the, no, I won't do that. Head start. So we did this, and we did this. And now let's look at this b here. So y equals sine b times x. So now, let's say b is, let's see. So we know this repeats at 2 pi, okay? So if that's not there, when x gets to 2 pi, then we get to this start over point. Let's say I put a 2 here, right? So I'll say y equals sine of 2x. Now, if I put 0 in here, this will still be 0. So everything will start here. But let's say I put pi in here. Okay, I'm going to input pi into this little machine. Now it's going to take the sine of 2 pi, which is right here. Okay? If I put pi in for x here, I'm taking sine of 2 pi. This is 2 pi. That's the sine of it. So I got to this faster than I normally would have. Normally, when I put in pi, I'm here. But because I put a 2 in front of the x, when I put pi in, I'm getting the sine of this, right? So what this does This is basically like an accelerator, an amplifier. It's a thing that makes it go faster than it normally would have, right? So the head start just starts you somewhere further than you would have started, but this makes you move faster because we still started at 0 here, but we only needed to put pi in to get here. So this is an accelerator. And then the last piece here, d. So this sort of happens like after everything else, right? So we've got all this stuff, which will take my sine function, and maybe it'll start it here, and maybe it'll make it go larger because we made the max and min, or maybe it'll make us go faster, right? All those things could happen from ABC. You know, we could have all of them happening, or just one or two of them happening. But then, after we do all of that stuff, we just add a number if we want to, right? So let's say I don't do any of that other stuff, and I just add d. What will happen to my sine function? So it's at 0 here. That's the 0 on the y-axis, right? I'm talking about this stuff. 1, -1, right? I'm talking about here. So whatever this is, let's say d is 5, then this would go up 5, right? Say that's 5. And this would go up 5, so that'd be there. And this would go up 5, so that'd be there. So the whole thing would be up here. So d moves the 0 to wherever d is. So if d was 2, after we did everything, we'd say plus 2, so the 0 would go to 2. And then this peak would go 2 higher, right? Wherever it was. If it was here, then it would go 2 higher. So what d does is it just moves the whole squiggle up and down. Well, what do you want to call that? I'm almost at 13 minutes, so we'll let you figure out a name for that. And hopefully this helped you to see just what all these little pieces do. You can apply the names you learn from the books to them, but it's good if you know what they all do and you have a real physical sense for each piece of it. I hope that helps.